Okay, I've gone ahead and I've drawn question 2 from the same handout on the board. Now I know there's a lot going on the board right now. I'm going to try to focus your attention right now to the diagram. So I've drawn the diagram. I've got our capacitor, our inductor, and our resistor all in parallel. So this is an RLC parallel circuit. We've seen these before. We've done them before. Nothing is new. The only thing new now is that it's what it's asking for. It's asking for power factor, for power, for VA, and for VARs. It's also asking for IT. We've calculated that dozens of times before leading up to this. So maybe the scary or overwhelming part at this point is what it's asking for. We're not used to calculating those units with this type of setup. So we're going to start this circuit. We're going to start answering these questions the same way we've been calculating these all along. Now you can see my color coding has changed. So my resistor is purple because it's the in phase part of the circuit. It's purely resistive. It's going to be our power or watts still. That component will end up being that part of the circuit. Now the inductor and the capacitor, I put those in black because we're not done with those two yet. Don't forget the capacitor is XC, the inductor is XL. But when we combine those two, we end up with X. And we'll decide then if we're either leading or lagging. And those two combined will be the reaction part. And that'll end up being our VARs. So I went ahead and I calculated 40 microfarads to be 79.58 ohms. I already did that. I didn't put it on the board because we have calculated XC multiple times. So I don't feel I need to add that step to the board. 120 volts across each rung. We're calculating the current of each rung, the IXC, the IXL, and the IR. Now, I took IR instantly and I put it over on our triangle there as 4 amps in purple. When you're looking over at the triangle on the left, look above, you'll see I drew a capacitor and an inductor. I reminded us that that's XC and that's XL, and combined they become X. Now for this circuit, because it's parallel, we're focusing on the current. So I want IX. So I've subtracted IXL minus IXC, and IX was 0.492 amps. The circuit, the influence was from the inductor, so it's more of a lagging circuit. So don't forget that IX, that was always that part of the triangle. That part of the triangle now, we're just calling it something different. We're going to end up calling it VARs. Okay, so I put it in red. And IT and VA, they're the same. So we're left to calculate IT. And IT is going to equal 4 amps squared plus 0.492 amps squared, square rooted. So it's going to be just over 4 amps. We're going to have a very small power factor, which is good. Or I shouldn't say a small power factor. We'll have a small phase angle and a very high power factor. Excuse me. So rewatch this video a couple times to get all your numbers in order. I'm going to finish this question off now by rubbing out the majority and redoing where we left off here.